Hi everyone! In this video, we are going to discuss implicit differentiation, right? In mathematics, some equations in x and y do not explicitly define y as a function x and cannot be easily manipulated to solve for y in terms of x, even though such a function may exist. The technique of implicit differentiation allows you to find the derivative of y with respect to x without having to solve the given equation for y, right? Okay, now we look at explicit versus implicit, right? What is explicit and what is implicit? Okay, let's say we use the same example from circle equation. Okay, x squared plus y squared equals to 1. Okay, 1 is radius of circle. Alright. Okay, under explicit form, okay, y is expressed as a function of x. So we can write y equals to square root of 1 minus x squared from this equation. Okay, we write y as a subject. Alright. But under implicit, the function is expressed in terms of both y and x. Okay, so we write x squared plus y squared equals to 1. Okay. Okay, both of these actually comes from the same equation. But explicit, we write y as a subject. And implicit, we express in terms of both y and x. Alright. The example we discussed earlier is the explicit differentiation in which we directly derive dy over dx, right? Alright, before we discuss further the example of implicit differentiation, let us first discuss simple example. Okay? Number 1, a equals to y. Okay? So when we differentiate a, it becomes a prime or dA over dx. Okay, we differentiate with respect to x. And then equals to, we differentiate y with respect to x, it becomes dy over dx. Okay, now we recall back when we differentiate x. Okay, when we differentiate x, it is equals to 1. Okay, why we have 1? Because actually, when we differentiate x, it is equals to dx over dx. Okay, we differentiate with respect to x, so must put over dx here. X from numerator is actually from variable x here. And x from denominator from differentiate with respect to x. Alright? And after we differentiate x, we have dx over dx, then we can simplify. So we have 1 here. Yeah, that's why when we differentiate x, we have 1 only, right? But when we differentiate y, we have dy over dx, and we cannot simplify dy over dx. That's why we still have dy over dx here, right? Okay, number 2, b equals to 2y. Okay, this is multiplication between constant and variable, right? Okay, when we differentiate b with respect to x, we can write db over dx or b prime, right? Equals to, okay, when we multiply by constant, we just put the constant in front. Then we differentiate variable. Okay, we differentiate y, it becomes dy over dx. Okay, so the answer when we differentiate to y, it is equals to 2 dy over dx. Okay, we recall back when we differentiate to x. Okay, when we differentiate to x, we have 2. Okay, because actually we just put the constant 2 and then we differentiate variable x with respect to x. So we have dx over dx. And dx over dx equals to 1. So that's why we only have 2 when we differentiate to x. But when we differentiate to y, we have 2 dy over dx. And we cannot simplify dy over dx. That's why we still have dy over dx here. Right? Okay, number 3. C equals to 3y squared. Okay. We can use power rule. Okay. When we use power rule, we can move power to the front and we multiply with 3 here. So we have 6y. And every time when we have y, we should have dy over dx. Okay. Okay, we recall back when we differentiate 3x squared. When we differentiate 3x squared, we have 6x. Okay. Actually, when we differentiate 3x squared, okay, we can write in terms of 3 bracket x squared. So, when we have bracket and the power of any value, we can use generalized power rule. So, we just put constant in front and then we move power to the front. We copy in bracket. Okay, so we copy x here and then power minus 1. So, we have 1 here. And then remember after that, we need to differentiate the function in bracket. So, we differentiate x, it becomes dx over dx, which is 1. So, after we simplify, we multiply 3 and 2x, so we have 6x. That's why when we differentiate 3x squared, it becomes 6x only. But when we differentiate 3y squared, it becomes 6y dy over dx. Okay? Okay, now, let's say we assume y inside bracket. Okay? So we have c equals to 3 and then we put y in bracket and then square. Okay? And every time when we have bracket, the power of any value, we can use generalized power rule. So when we differentiate, okay, we still put constant in front here and then we move power to the front. Alright? And then copy in bracket, okay, and then power minus 1, and then differentiate in bracket, we have dy over dx. Alright? And after that, we simplify 3 times 2, y, so we have 6y dy over dx. Okay? Same answer. Alright? Alright, now look at number 4. Okay, if we have d equals to square root of y. Okay, first step, when we want to differentiate square root function, we need to change into the form of exponent. So we need to write y the power of half. Right? And then we can differentiate using generalized power rule. Okay, when we differentiate d, it becomes dd over dx, okay, or d prime, okay. So when we differentiate y bracket the power of half, when we use generalized power rule, we move power to the front, we copy in bracket and then power minus 1 and then we differentiate in bracket. So we differentiate y, it becomes dy over dx. And then we simplify, so we have 1 over 2, we move the power of half to denominator, so we have y the power of positive half, and y the power of positive half is third y, right? So we have 1 over 2 third y dy over dx. Alright, we recall back when we differentiate third x. Okay, we change into the form of x the power of half, and then we move half to the front and then x, and then we write power minus 1, so we have half minus 1 equals to negative half. And then we differentiate the function in bracket, so we differentiate x, we have dx over dx. But we can simplify dx over dx. So the answer is 1 over 2, we move down the power of negative to numerator, so we have x the power of positive 2 or we can write set x here. Okay, so when you compare from number 1 to number 4, okay, every time when we have variable y, okay, must have dy over dx at the back, right? Okay, now we look at simple example number 5. Okay, if we have a equals to x times y, okay, this is actually multiplication of variables. Okay, and to differentiate multiplication of variable, we need to use product rule. Okay, so using product rule, okay, a prime equals to vu prime plus uv prime. Okay, and then we define u and v. Our u is x and our v is y. And then we differentiate. We differentiate u equals to u prime. We differentiate x equals to 1. And then we differentiate v equals to v prime. And we differentiate y equals to dy over dx. And then we substitute into product rule formula. Okay, so after we substitute, we have a prime equals to, we multiply v and u prime, so we have y times 1 here, we have y, plus we multiply u and v prime, so we have x dy over dx, right? This is the answer when we differentiate x times y, okay? But when we differentiate 2 times y, okay, we only have 2 dy over dx. Okay, this is from simple example number 2 in the previous slide, right? Okay, what we do is we just put constant in front and then we differentiate variable y. Okay, we differentiate variable y, so we have dy over dx. Okay, this is multiplication between constant and variable, so we can still put the variable. Okay, we no need to use product rule, but we still can use product rule, but the technique is quite long. Okay, why we still can use product rule? Because let's say we define u equals to 2, okay, and v equals to y. So we differentiate 2, it becomes 0, and we differentiate y, it becomes dy over dx. And then we substitute into product rule formula. So we have a prime equals to vu prime plus uv prime. And then we replace v times u prime, okay, y times 0, which is 0, plus u times v prime, so 2 times dy over dx. And the answer equals to 2 dy over dx after we simplify. And when we compare, okay, it is equivalent. So means that we can use both of this method. But, okay, please choose the simplest one. Okay. Alright. When we differentiate using product rule and we just put constant in front here, we get the equivalent answer because when we differentiate 2, it becomes 0. So when we multiply v times u prime, we get 0 here. Alright? Okay. But, okay, if we have 2 multiplication variables, okay, we cannot do like this. Okay, we cannot just put constant variable x in front. Okay. If we use this step or this technique, okay, we have x and then dy over dx here if we use this technique. And the answer, when we compare, not equivalent. So that's why if we have multiplication of variable, we only can use product rule, right? But if we have multiplication between constant and variable, okay, the easiest method is we still put constant in front, and then we differentiate variable with respect to x. Alright? Okay. But, okay, student always do like this. Okay. From a equals to x times y, okay, they differentiate a, so it becomes a prime, and they differentiate x equals to 1, and they differentiate y equals to dy over dx. What they're doing is they differentiate one by one. Okay. When we compare, okay, to this answer, it is not equivalent, right? So this is wrong method, but it is very common mistake. So please be careful, right? Okay, but let's say if we have a equals to x plus y. In between now is plus. Just now we have in between is multiplication operation. Okay, now we have in between is plus sign. Okay, so in this case we can differentiate one by one. We differentiate x equals to 1, and then plus we differentiate y equals to dy over dx. Okay, we can differentiate one by one if in between is plus or minus sign, because we use sum and difference rule, right? But when in between is multiplication operation, we cannot differentiate one by one. Okay, if we have multiplication of variables, okay, variable times variable, we need to use product rule, right? Okay, this is correct, right? Means that when we have in between is plus, we can differentiate one by one. This one is wrong. Means that if we have multiplication operation in between, we cannot differentiate one by one. And this is correct. Okay, when we have multiplication between variables, okay, x variable, y also variable, so we need to use product rule, right? Coming up next, more simple examples involving implicit differentiation. Thank you for watching. Stay tuned. Bye. Assalamualaikum.